There, and welcome to the first activity in having fun with chemical theory. In this activity we're going to be looking at density. It may be useful for you to download the Activity 1 PowerPoint or Keynote file to allow you to make notes on what we're going to discuss in this video. Okay, the first thing we need to understand is materials. Materials are all around us and they are made up of three states of matter. But what is matter? Well, basically matter is what the material is made out of, and it comes in three forms. The three forms of matter are solid, liquid, and gas. Now they have specific properties. We'll be looking at those properties later in Activity 2. Now, when we're looking at a solid, generally we talk about a solid in terms of density. Now the idea is that all solids are different. Okay, now density deals with how much material is in a specific amount of space. For example, if you take a piece of cork and put it in water, it floats, it's still solid. Take a piece of iron though, put it in water, and it will fall and sink to the bottom. They're both solids, but there must be something different about them. Now, what density looks at is how compacted together the particles are. In the form of cork, the particles are not very close together, there's lots of air gaps, and as a result it floats on water. However, if you look at iron particles are packed together incredibly tightly, so you've got a huge number of particles in a very, very small space. As a result, it sinks. Now, density can be calculated using the following equation. You need to have two main components, and you can measure these experimentally. The first component that you need is the mass. This is then divided by the volume. So when you're doing a calculation, make sure that you've got your mass, in this case in grams, and your volume in centimetre cubed. And it's very simple to work out the density, just divide the mass by the volume. Let's have a look at an exercise below. Now, at this point you can stop the video and have a go at the exercises using the formula above in the red box. Also, try and work out of the three objects which is the heaviest and which is the densest. Do that now. Hi, welcome back. So how did you go? Well, let's have a look and check your answers. Well, to start off with, let's look at object A. We're going to work out the density of object A, which has got a mass of 19 grams and a volume of 4 centimetre cubed. So what we do is we divide 19 by 4, and the answer should have come to 4.8. Did you get it right? Well done. Now for object B, we do exactly the same. It's got a mass of 26 grams. It's got a volume of 8 centimetre cubed. Divide 26 by 8, and we get 3.3 grams per centimetre cubed. And finally for object C, we have a mass of 17 grams, a volume of 2 centimetre cubed, so we divide 17 by 2 and we end up with 8.5 grams per centimetre cubed. How did you do? Did you get all three right? Congratulations. Now we need to interpret what we've got here. Now the first question asks, which of the three objects is the heaviest? Well, in order to work this out, we need to look at the mass column. The mass column will identify the weight of or the amount of matter that is present in the object. In this case, the one with the biggest mass, or the heaviest, is object B, because it has a value of 26 grams. Now when it comes to which is the densest, obviously we've got to look at column 3. We look at the density column and we see that object C is actually the biggest. Now, that seems confusing in some ways because you'd think, oh, well, why shouldn't object B be the densest? Well, the reason is that although object B has the biggest mass, it takes up more space. So there's lots and lots of space which is going to be inside the actual material. For example, I could have a ton of cork, place a ton of cork in some water, it'll still float, but it will be taking up a huge amount of space. Okay, well that explains density. I hope you found that useful. By all means, link this with your practical that you did in class, and hopefully you should be okay. Alrighty, thanks for watching, and I'll join you again in the next activity, which will be looking at particle theory. See you later.